Welcome to this tutorial session. In today's question, we have the cube root of log to the base 2 of x all over 2 is equal to log to the base 2 of root x to find the value of x. Let's get started. Cube root of log to the base 2 of x all over 2 is equal to log to the base 2 of root x to solve for x. The first thing to do is to remove this cube root. So we are going to cube both sides. Cube both sides simply means we raise the power to 3. We cube both sides. This cube will cancel the cube root. So we have log to the base 2 of x all over 2 will be equal to log to the base 2 of root x cube. Now let's look at the right hand side. We're going to use the law of logarithm, which says log a to the n to the base a will be equal to n log a to the base b. That means the power is multiplied before the log. Now let's look at this. Root x means x to the power half. So our n here is a half. Let's apply this law. When we apply this law there, we're going to have, okay, let's write it back. We're going to have log to the base 2 of x is equal to a half log to the base 2 of x all raised to the power 3. When we apply this law, let's go gradually. This power 3 out here is going to affect this half and will affect this log. Alright, so we have log to the base 2 of x all over 2 is equal to a half raised to the power 3 is 1/8. We have 1/8 log to the base 2 of x. This one now raised to the power 3. That's what we have. Okay, so how do we proceed? We can see that 2 is here. To eliminate this 2, we can multiply both sides by 2. So if we multiply here by 2, log to the base 2 of x all over 2. I will multiply this side also by 2. 2 into 1 all over 8 log to the base 2 of x cube. This 2 cancels that 2. 2 here, 1, 2 there, 4. So we have log to the base 2 of x is equal to 1/4 log to the base 2 of x cube. Again, take note that log to the base 2 of x cube is not the same as log to the base 2 of x cube. This is not the same as that. This one is log to the base 2, 3 log to the base 2 of x, this one. But this one cannot be expressed as such. So no confusion here. Alright. So, progressing, we now have log, well, so from here, how to go about to get x? To make things a lot better, we have to carry out a transformation. Let's carry out a transformation wherein we are going to bring in a new variable to replace log to the base 2 of x. Since we have log to the base 2 of x common on both sides, log to the base 2 of x, log to the base 2 of x. So if we let for example a new variable y to be log to the base 2 of x, if we let that All right, so let us rewrite this using that new variable. So we're going to have y will be equal to 1/4 y squared, y cube, sorry, 1/4 y cube. That's what we obtain. So let us solve for y. How do we solve for y? We take this left hand side and bring it to the right hand side. So that we'll have 0 is equal to 1/4 y cube minus y. All right. So let's rearrange it. Let everything look better. Let's take this right hand side completely and bring it to the left hand side and take this 0 to the right hand side. So we have 1/4 y cube minus y is equal to 0. Now the left hand side, we see that y is common. Let us factorize out y. We're going to have y outside into 1/4 y squared minus 1 is equal to 0. All right. Now let's look at what we have inside the parentheses. It's actually a difference of 2 squares. We should be able to see that. Okay, let's write it out so that we will see the difference of 2 squares clearly. This is y into a quarter is the same as half. So this can just be written as y all over 2, all of that squared. Y all over 2 squared minus 1 can also be written as 1 squared. Remember, 1 squared is just the same as 1 equal to 0. So that we now see that this is a difference of squares expression. So that we can use the difference of squares identity there to resolve this. Okay. Now let's apply the difference of squares identities to what we have inside the parentheses. We have y into y all over 2 minus 1 into y all over 2 plus 1 equals 0. Okay, this is the expression we get after applying the difference of squares identities. So we have the product of two expressions giving us 0. It simply means either y is equal to 0, this first expression, or this second expression is equal to 0. Y all over 2 minus 1, y all over 2 plus 1 equals 0. Okay? So we have these two equations to solve. Now let's take the first one. If we take the first one, case 1, y equals 0. What is y? Y again is log to the base 2 of x. So we're saying log to the base 2 of x equals 0. This means that what? It simply means when we raise this base to this power, we are going to get that. It simply means x is equal to 2 to the power 0, which means x is equal to 1. That is our first solution. Okay, x equals 1 is our first solution. Now let's take the second case. Let's take our second case. Y all over 2 minus 1 into y all over 2 plus 1 equals 0. So we're taking the second case. Y all over 2 minus 1 multiplied to y all over 2 plus 1 equals 0. Here we have product of two expressions giving us 0. So we'll carry out the same reasoning. Either this first expression is 0 or this other expression is 0. So either y all over 2 minus 1 equals 0. Okay, let's progress with this one first, which also now means that y all over 2 will be equal to 1. Okay, which also means when we multiply both sides by 2, it means y is equal to 2. But we remember again that y is this expression up there. So it means that log to the base 2 of x is equal to 2. If this is the case, again, we carry out that process. When we raise this base to this power, we are expected to have that argument. So this means that x will be equal to 2 to the power 2, which is 4. So this gives us our second solution for x. Now let's take the last case, y all over 2 plus 1 equals 0. Y all over 2 plus 1 equals 0. So we have y all over 2 plus 1 equals 0. This means y all over 2 is equal to negative 1, which means y is equal to negative 2 when we multiply both sides by 2. But again, remember y is log to the base 2 of x. So this means log to the base 2 of x is equal to negative 2. Alright, again, when we take this and raise to that power, we expect to have the arguments. So this gives us the value, the third value of x, which is 2 to the negative 2. And 2 to the negative 2 simply means 1 all over 2 squared, which is equal to 1/4. So our third solution is x equals 1/4.